I need to translate these stick structures for you. These are organic chemicals. Every corner has a carbon atom, so we need to remind ourselves that carbon comes in with 4 unpaired valence electrons. So each carbon atom makes 4 bonds. And so let me translate this into something that resembles a Lewis dot structure without actually the dots. This means there's a carbon on the end of it, so I'm going to start there. And it's attached down here to another carbon, so it must have 3 hydrogens on it. This carbon is double bonded to another carbon here. And there's a single bond to another carbon here. So this one has 4 bonds already. These each have 2 more bonds. And so this one needs a hydrogen, and this one needs 2 hydrogens. There's another carbon down at the bottom of the ring. And so this one must need 2 hydrogens. This one must need 2 hydrogens. This one has 2 things coming off of it, which means there are 2 carbons, 1 off each one, and each one is a CH3 group. Oh, I don't have a hydrogen here, actually. I have another carbon, and it's double bonded to a carbon. And so this one must need a hydrogen. And then this one is single bonded to a carbon, so it must need a hydrogen. This is double bonded to a carbon and has another CH3 group up here. This carbon now has a single bond, so it must need a hydrogen. There's a carbon and then a double bond, but this one has another, whoops, not yet. Sorry about that. Let me actually get this backbone structure in, and then I'll fill in the things that come off of it. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9. I have a total of 10. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right. So the second one up has a bond. The second one up has another carbon here. 1, 2. This one has another one. And then this one has another one. And then this one is part of a ring. And it's a 6-membered ring. So this one has methyl groups. That's what the CH3 is called. There's another one down here. This one is a methyl group. This one is a methyl group. This is a methyl group. And I think now this looks like this, except I have to put the rest of the hydrogens in. So this one has 3 bonds already. I need 1. This has 3. I need 1. This has 4. This has 3. I need 1. This has 3. I need 1. This has 3. I need 1. This one also. This one now has 4. This one now has 4. Let's see. This has 4. This one has 4, 4. This one has 2 hydrogens attached. So does this one. So does this one. And so this long explicit structure has a shorthand way in these stick structures. So every kink in these stick structures says I have a carbon atom there. It's showing you the carbon-carbon bonds. Any other bonds that are here are also carbon-carbon. The hydrogens are left off. And we have to count up to 4, only 4. You can do this on one hand. And so any carbon that does not have 4 explicit bonds to other carbons must have some hydrogens on it. And this compound is called beta-carotene. And surprisingly, it's found in carrots.